Thanks for tuning in to this session of Beyond Bitcoin's Delegate Edition. Giving potential delegates a unique opportunity to discuss their ideas, plans, and goals to help fortify the BitShares ecosystem. If you're a potential delegate and would like to create your own hangout, then please send your request to beyondbitcoin@gmail.com. Are you finding yourself addicted to our hangouts? Need the next fix? Then please vote for our delegate, fuzzy.beyondbitcoin. Again, that's fuzzy.beyondbitcoin. In addition, you can also check out our new website, beyondbitcoinshow.com, for the latest recordings and events. Now let's join in with our featured delegate.
Welcome to another Beyond Bitcoin Delegate Hangout. Today we are joined by Indolering to talk about his delegate proposal to help work on the .p2p functionality for the BitShares flagship decentralized exchange deck. If you enjoy these Hangouts and would like to keep them open and running, please consider voting for the fuzzy.beyondbitcoin delegate. Follow us on Twitter @beyond_Bitcoin and share our recorded Hangouts with your friends and family. Don't forget to check out our new website at www.beyondbitcoinshow.org.com for the most recent shows that we offer. The format for these Hangouts, we will start with 5 to 10 minute project introduction from Indolering. We will then move on to community questions. As a community member, I will ask my own questions. If you do not have a microphone or are uncomfortable asking a question out loud, please ask it in the chat box in the side panel, and I will do my best to fit it in. With that said, thank you, Indolering, and are you ready to begin?
Yes, I'm ready to go.
Could you give us a little bit first off, like a little bit of a background about yourself for those who haven't read your delegate proposal? You had some interesting stuff going on in there, especially something interesting to me was mention about working with Mozilla. But please go into.
So first of all, it's pronounced Indolering, which is minor. I started, I'm working on, I think I should explain first what .p2p is, which is the decentralized top-level domain. So like so many things, Bitcoin, and cryptocurrencies have revolutionized. One of them was the ability to create a censorship-resistant domain name system. What the domain name system is, normal domains like, example.com, example.net, those sorts of things. What that does is it provides kind of a layer of abstraction between kind of a human, web domains in general, and the URL bar provide, what is a usable remote function call interface for the web, which is to try to kind of unpack that a little bit. It means that, like within a computer system, you need to be able to say, okay, I want this function executed on this remote computer with these variables. And so the URL bar is kind of this very strange miracle in that it is a usable remote function call interface, right? We deal with these kind of remote function call interfaces in programming all the time. And the web is as powerful and as all-encompassing as it is because it has this text interface that normal people can use, which is very, very rare. People really didn't like using the command line back in the days of DOS and everything else, and everything is kind of a GUI now. And the browser is this very interesting, very unique area where you still have this textual interface that lets you access all this content on the web. And so the early on, we tried to kind of create a more censorship-resistant, we've been trying to create a more censorship-resistant system, a domain name system, and this was stymied up until Bitcoin because of this interesting property of domain names. So the thing about domain names is that if you have a human, domain names that have human meaning to them, so, like Wikipedia or Facebook, there's no real intrinsic meaning in those names, but they are something that we can use, and it's something we can remember. It's something we can assign meaning to, and so there was this conjuncture about these naming systems called Zuko's triangle, and the original formulation of this conjunction is rather abstruse, but it kind of boils down to essentially, if you have a decentralized system, before we had a decentralized banking system, if you had names and you assigned values to them, you could introduce censorship by blocking payments for certain domain names, essentially. If you then got rid of these payment systems, then squatters could come in and take all these full domains and just, and have no reason to sell them. So what Zuko's triangle says is you can't have a domain name system, you can't have normal usable domains in a decentralized fashion. And then Bitcoin came around, and then a few smart people, including Aaron Schwartz, said, hey, we've got a decentralized banking system, we can make a decentralized domain name system now. We can make this decentralized domain name system, which means that we can now have anonymous, usable anonymous networks. We can now make it so that there's a domain name, there's a top level domain that no government can go after, that we can use Bitcoin's ability to make trusted transactions between untrusted parties. We can use that to assign value to domains. We can sell domains that way. And this was really exciting. And this was back in around 2011. This happened, and I had grown up, knowing about Zuko's triangle, knowing about this problem, and watching every attempt at a decentralized domain name system come up and fail. And just there's a previous .p2p project that failed, and it was because couldn't get around Zuko's triangle. So in 2011, I was really excited. I said, "Hey, great! Problem solved. We've solved this tough theoretical issue. We're and." It's just an engineering problem. We'll just wait to see what happens. And then I checked in with the project a couple years later and found that it really hadn't gone anywhere. And so, I'm a usability engineer, and I started asking myself, why hasn't it gone anywhere? And so I started doing a lot of usability work on it. I kind of created this early version of trying to make a backwards interoperability system that was called Speech.is, and that's now evolved to something even more advanced since then. And I've also been involved in a bunch of other initiatives, such as trying to price it and
Not everybody understands what domain name resolution is, right?
Okay.
Could we just give a quick primer to anybody who's listening who's a cryptocurrency fanatic but doesn't quite understand
what it means?
Yeah.
So actually, the domain name system is really, the very first one was literally an index card in someone's wallet. So this guy had an index card that had on one side it had names that people wanted, such as like example.com, and then on the other side it would have an IP address. So a network address for where that server was that represented example.com. And he would get a phone call, and he would add it to this thing. And then once he got big enough, he'd go to his computer and he'd enter it in, and it, and there was, this hosts.txt file, which is, literally just, at the time, it was literally just that index card. It was a name and then an IP address on the other side. And so that's what the domain name system is it's a big phone book that connects human meaningful names to network addresses that computers are more comfortable with. And that's what we're creating. And so in the actual blockchain, what that looks like is essentially you have a digital asset, and it is a domain name that is controlled by a public-private key. And then you request that, when you ask for that domain name, you're essentially returned routing information. So what IP address goes where, what subdomains, so if you have, let's say there's a subdomain for your blog, like blog.example.com, and maybe you're having Tumblr manage your blog for you. So under blog.example.com, it would actually have a link or the address for your Tumblr blog. So on the browser end, it looks like it's at blog.example.com, but the server actually fetches it from tumblr.com.
Just to back up for a second, an IP address would it be safe to say that it's kind of like a home address? And if somebody wants to send something somewhere or wants to visit a site or a home, they need the address to get there.
I prefer saying it's like a telephone number, but yeah, it's the same thing. It's an address.
Only it's an address that a computer understands as opposed to a human. So it's a little bit harder to necessarily remember the number because it's actually a little bit longer than what humans tend to be able to remember.
I mean, it's almost impossible. So, I mean, if you remember a time before cell phones, you maybe had maybe a dozen numbers or so memorized. At least, I was kind of a kid, so maybe adults had more, but really only had a few telephone numbers ever memorized. And then you had an address book. And then if you needed to find the number for, whomever, you'd actually go and pull out the telephone book and look it up that way.
So that would be kind of like the domain name resolution or telephone name resolution system.
Exactly. Yep.
Now, how does a government or how does any institution that wants to oppress its people, how can it use the control of these domain name services to harm its citizens?
Right. So what's irritating is that the domain name system used to be kind of sacred territory. It was not involved in the DMCA, and it was ignored for a long time because really, if you want to go after people, you go after hosting, right? You go after the people themselves, or you go after the money. And the domain name system was seen as, it's an abstract concept. Its domains are in the ICANN's view, ICANN, the corporation that manages all this stuff, the nonprofit that manages all this stuff, and every other intellectual that cares about the internet sees this as a place name. So it's kind of like saying the United States of America is a place name, and you can't take that away arbitrarily, right? You can't, or you can't treat that as an asset class. Unfortunately, the law in America and in other places has determined otherwise, and they have been using this to essentially take all these domains willy-nilly. And it's been very, very scary in the United States. It started in I believe it was 2011, with about 87 domains that ICE, the Immigration Enforcement Agency in the United States, went after 87 domains, said that they were selling counterfeit goods, and it's been increasing exponentially every year. And in this past year, in 2014, there was actually the other scary thing is that basically any corporation can go to American, because it's .com, .net, .info, and .org are all managed by a U.S. corporation. Basically, anyone can go to a civilian U.S. court and kind of get these domains handed over to them willy-nilly. And the people that own those domains do not get prior notification. They don't get a chance to object to this in court, and they're just taken arbitrarily. So we're not only just seeing ICE doing this. In 2014, there was a single civil court action that resulted in just under 5,000 domains being taken. And the only reason that anyone knows anything that all of these domains were taken by this one legal action, because the WHOIS information changed. So the records being returned by these domains, the meta information about them all changed towards some Bob at domainsales.com.
So WHOIS basically, could you explain
kind of meta information about domains? It's kind of not important. The important thing is that 5,000 domains were taken, and we're still we still haven't been able to see the court records as to the logic as to why. And that's really scary. And the United States, there's a bunch of other awful examples, but the U.S. Embassy in Mexico. The other way that they can do this is they basically just contact your DNS provider or your registrar, and basically anybody with a badge and a fax machine can get these domains yanked, or at least temporarily they can go and just mess with them. So there's actually a U.S. Embassy in Mexico that called up GoDaddy and said, hey, there's this Mexican political protest site that they didn't like, and so they reported them and got the domain shut down. And this is a U.S. embassy. The United States has free speech as its first enumerated constitutional right, and we're just arbitrarily shutting down speech that we don't like. And what's very interesting about this is that back in the Pentagon Papers, one of the things that they argued about was this concept of the name's going to escape me for a second, but essentially not being able to preemptively stop speech. So, there's a lot of law about what you say can get you into trouble, but preemptively stopping speech, preventing future speech is really, really not okay. But that's essentially what domain name censorship does, is it prevents future speech, and it doesn't go after people for what they do. It goes after for them for what they could be saying. And what's irritating is that, it's kind of the 21st century version of dope on the table, and that politicians and law enforcement, it's very cheap for them to go out and shut down a bunch of domains, just like it's cheap for them to go out and arrest a bunch of street dealers. But it does absolutely nothing to stop the sort of bad activity that you don't like seeing on these domains. So if you don't like file sharing, you should go after the people that are perpetuating it. You should go after their servers and where it's being hosted. And you should go after the money. But with DNS censorship, they don't have to do any of that. It's very, very cheap and easy for them to not have to do their job, essentially. So what we're trying to do is we're trying to set up a few domain names, a few, a .p2p for BitShares and .bit from Namecoin. We're trying to set up safe havens from all this shenanigans. And we're trying to make, a place on the web where you don't have to appease the government in order to have a voice. You don't have to appease any single government in order to have a domain name, and have that domain name safe from seizure.
It's very interesting because there have been times I watched this stuff personally, pretty heavily, and you're right. This is our free speech, right? The internet to me is like, you had the Library of Alexandria way back in the day, where it was, it was this place where everybody could go and get this information. And you have these large libraries that, information is wealth for people. And if you have access to that, go ahead.
Yeah, and what's interesting is that it is the domain name system. It is the URL bar and having this usable function call interface that hooks you up to the largest distributed information system ever created. And that's really powerful. And it's interesting because, one of the things, I am really bullish, and what I think that .p2p's main focus should be is universal resolution everywhere by default. The Namecoin team is more focused on Freenet and Tor and those networks, and I would like to get P2P working on those as well. But one of the things that has prevented Tor and Freenet and these other censorship circumvention networks from having anonymous publishing is the lack of a usable domain name system, the lack of a system of a usable remote function call interface. And that's really the interesting key, is that it allows us to go out and get information from anonymous publishers and in a usable fashion. And that's really the crux of what we're doing.
So could you kind of touch upon, DeLulo is asking a question regarding, does the DNS server have a one-to-one copy of the ICANN database?
So the DNS server and the ICANN database are kind of the same thing. So yes and no. The name of the game with DNS and most of these things is kind of delegation and reducing the amount of information that you have to store. I'm not sure how wonky we want to get into here, but if you actually look at the ICANN's database, ICANN basically has, the .com database, which is, tens of millions of domains, if not hundreds of millions. I'm pretty sure it's hundreds of millions of domains, and it's 9.6 gigabytes if you download the whole thing for .com, and it is just line after line of name server at this IP address, right? Like it is, don't ask me, ask this server over here. And so ICANN doesn't want to have to do everything. It acts as kind of this is the person you should go talk to if you want to know more information. And your local DNS server actually queries the correct DNS server for some website. It queries that, and then it caches those results locally. But essentially what is being stored in a decentralized database, you can store the full domain information, but really what you should be storing is 3 pieces of information. So basically the name, the domain name itself, a URL or a network address for your name server that provides the DNS information, and then cryptographic information, basically a hash of your public keys. And so that when you go and you query that DNS server, it comes back and you check what the cryptographic is their cryptographic information correct? Yes, okay, great. So what is stored in the .ptp database is very minimal. It's just enough to get you going. But yeah.
Tom's actually asking here. He says, I would like to hear a brief history of .p2p, as this issue, in parentheses, .bit addresses, is what brought me into BitShares in the first place. I've been somewhat disillusioned with the loss of focus on DNS replacement that was once a major element in the BitShares ecosystem. I
kind of agree with you guys, and so as Fuzzy remembers, my my initial posts to the forum were that they were bringing me out to kind of check me out, and my secret mission, my not so secret agenda, was to try to revitalize their .p2p effort and convince them that it's something that's worth spending time and money on. And when I got there, it wasn't because they were disinterested in doing .p2p. It was because the team was spread pretty thin, and you guys had a lot of stuff going on. And I think there's I kind of spent some awkward time arguing about the ID system, and that was actually just kind of the result of some other conversations I had. The issue there was, they needed to get 1.0 out. They needed to focus on the core technology, and I'm kind of the person that they were finally able to kind of bring on to work on and to focus on .p2p directly. The history of it was that as far as I know, there was a lot of planning going on, but there wasn't a totally cohesive long-term plan. And so what I'm kind of focusing on now, I kind of wrote up a roadmap. I think I made a mistake in writing that roadmap in so much that it seemed a little too definitive. That roadmap is going to change when we finish the journey. It's definitely not going to be the roadmap I initially wrote out. But I do think that what I'm trying to do now is trying to set up and get a lot of the fundamental technologies figured out, and then do kind of a real launch of .p2p in about a year or so.
Joey D has mentioned on a couple cases here in the in the chat channel about the role of certificate registration for HTTPS, which is the secure version of hypertext transfer protocol, which is the protocol that underlies all this. Could you talk a little bit about that? And then actually, I would also like you to, if you could, go into a little bit of what you're hoping to do with the delegates that you're wanting to run. Give us a little bit of details about that. So for those who haven't read the proposal.
Okay, so there are 2 items. I'm trying to give listeners a background here. Encryption technology, encryption on the web has this very bizarre system of these I have a solid hour-long presentation on this, actually, that I've been working on about these. It's essentially, it's kind of like the idea of a notary, right? A notary republic back in the day that would say, okay, I checked this person out. They're Bank of America. They're the actual bankofamerica.com, and here's my encryption certificate. And they charge a bunch of money for this service, and it's really a stupid service. And it's just kind of, it was the result of a 4 a.m. decision at Netscape when it was an embattled startup, and it was from the person who developed it, the engineer who worked on it. He just said, yeah, it was a hand wave, right? It was something that they just kind of came up with. So you have all these certificates. You have to pay these certificate authorities for them. It's a ridiculous system. And a lot of people say, well, let's build a parallel certificate authority system. And the conception I want to clear up right now is that we don't need to. The certificate authority system, DNS is the same thing. So what DNS does is it says, this is the person you want to talk to. And when it's encryption, essentially what the certificate authorities were saying is they had another system of saying, this is the person you want to talk to. And so the difference was that DNS wasn't, and still largely is not, secure, right? There's no cryptographic. We're now working on this. It's called DNSSEC. And so it is encrypting, or not encrypting, it is making everything verifiable using cryptographic methods. And so once you have the DNS itself that is secure in terms of cryptography, you can then say, okay, here's the hash of the public key that you should trust, and that's it. And so you just put your public key in your DNS record because you're saying this is the person you want to talk to, and here's their cryptographic information. So we will be providing an alternative to the certificate authorities, but we don't have to build a whole new system. We just have to add a new type of record to the existing domain DNS system that we have.
So essentially, we can boil it down to saying, right now, it's very similar to the other middleman models, where middlemen get into places of authority who really can abuse their power once they're there. Mm-hmm. And essentially, you're forced to go through these people in the current ecosystem. Mm-hmm. And that gives governments and all sorts of people who are maybe a little bit, might even sometimes have the best intentions.
Oh, yeah, absolutely. They have the best of intentions. The problem is that the system that they created is just ridiculous. The problem is that the early web was built on the idea that there might be 12 sites that would ever need cryptographic information, right? It was a one-way system. They were thinking of it as newspapers publishing to websites. There was not really, there was comments and there was some other small stuff, but the two-way communication system was very limited. And they thought, there might be a few banks that need encryption. Maybe, the idea, email was not something you did over the web. Email is what you had a email client for, just like you have the browser for a web client. And everything radically changed as a result of, basically what the web did was it has this remote function call interface, so it was able to eat up email and, even Bitcoin wallets and everything else are, the most popular ones are done all over the web because of this amazing interface that it provides. But yeah, you're right. You don't need these really archaic systems and these really weird ways of doing things.
Can I ask you a question here? This is a recent news story. I'm sure you're familiar with the term net neutrality. And this is by a guy named C. Mitchell Shaw in the New American. It's titled Net Neutrality is a Trojan Horse Virus Infecting the Internet. And he essentially talks about the FCC chairman publishing an op-ed in Wired talking about the issues with net neutrality. And here's just a little snippet, and I'd like your opinion on it. FCC commissioner sees the newly proposed regulations as a real threat to the liberty of the internet users. Commissioner Ajit Pai, and I probably have destroyed his name, and I apologize, tweeted a picture of himself, holding a plan with a picture of President Obama in the background. His tweet read, "Here is President Obama's 332-page plan to regulate the internet. I wish the public could see what's inside." So this is essentially something that the FCC is looking at, just going ahead with this regulation without any input from the citizens before it's utilized. Do you have any thoughts on net neutrality and what's going on with this? Or do you know anything about this?
Right. So I've actually got way too much background in this. So my background is doing a lot of political psychology work. So let me just start off by saying I am an unabashed supporter of net neutrality, but I will say that the regulations for net neutrality are a really shitty compromise. And they are a crappy compromise because essentially we don't have real competition. And so there's two ways that we can fix this, and which is what the strong Title II reforms would be unbundling services. So if you remember back in the 90s, back when everything was dial-up, and you didn't have to have permission from the phone company to set up an ISP, there was a huge amount of competition. And there was, even locally in Podunk, Idaho, there was at least, a couple local ISPs. And there was a huge amount of competition, and it drove prices down. And it was great, even with DSL, because it was DSL, and it was under a specific type of regulatory body. It was I'm not going to say the exact ones I think it was, but essentially anybody could be an ISP for DSL, and that was great. But cable was not classified this way, and you couldn't get bulk ISP. You couldn't have people competing for ISP services over cable. And then I think they did some reclassification, and I'm not sure if they got rid of that with DSL as well or what happened. But essentially now there is no competition. And so in other areas, they don't need explicit net neutrality regulations because there's competition to begin with. So, all of these, I would prefer not to have these regulations as well, because there's a lot of very fair criticisms. There's essentially a home line is not supposed to, when they figure out the pricing for home internet connections, they're not the same as if it was a business that was providing servers on the back end, right? And so if you're overusing that service a little bit, it makes sense that, especially when everybody else is online, that it gets throttled a little bit maybe. But, there was a recent article out that basically showed that, ISP, the profit from internet connections for Time Warner was something like 97% profit margin. Now that number's a little cooked because it doesn't include voice support, it doesn't include building out all those things. But essentially, as you get bigger, there is no real competition. All these data caps and stuff are absolutely ridiculous. If you run your own server, you know exactly how cheap it is to have a 100 megabit connection unlimited, for $5-10 a month. So I agree. On the one hand, it sucks that you're getting into network management stuff. On the other hand, the reason you have to do that is because they're not willing to have real competition.
And by the way, don't forget that in the US, the cable companies actually already got the money to improve the bandwidth, but they didn't use it.
Absolutely.
from your taxes. So you already paid for it, and now you're paying again for these data caps.
They took all these regulations. They have been jerking us around for years, and they also do evil, horrible things like small ISPs trying to get started up. Ars Technica had a great article on this. Small ISPs trying to get going face, two things from the incumbent ISPs like Time Warner. They sue the shit out of these small ISPs, forcing them to spend a ton of money on lawyers and frivolous lawsuits, and they sit around and they try to create all these anti-competitive laws.
And I get this straight. They're using our tax dollars to build out this infrastructure.
We got several $100 million in tax dollars to improve the data limits in nationwide, and they only used it to fuck you over.
Yeah, they did not take. They had all these taxes that were then repealed from them. There's all these sweetheart deals that said, "Oh yeah, we need a ton of money to improve this infrastructure," and they don't do it.
So they use the money instead to prevent competition that would actually improve our internet bandwidth,
right,
and the quality of our service.
Right. And I think the reason that Google Fiber started out was essentially they said all these small ISPs are never going to be able to get anywhere because they can't fend off these lawsuits, and they can't go to the legislature. Because the other thing that they did is they used, they say they don't like regulations. They love regulations when they can use it to stifle competition. So there's a bunch of poll access issues and a bunch of basically protectionist bullshit that they passed locally that they're using to stifle competition. So Google has been doing a lot of good work in that they can fend off those lawsuits, and they can raise enough awareness around an issue and enough political will to get concessions and get these regressive regulations removed.
This is a very basic question. So on the one side, there are, of course, the people that build the fiberglass connections between different ports, or like between the people basically. And but are those the same people that you call ISPs, or are the ISPs the people that buy from the people or from the companies that build the physical infrastructure? Well, I'm trying to get clear on what an ISP is.
Well, I think we're kind of getting a little too far off topic here. We can get into a very deep discussion of who should own, access to, how access to this infrastructure should be regulated. But we're going to start getting into real flame war territory if we start talking about all that. So I think the general gist of what I'm trying to say is there's no competition, so you have to deal with all these shitty regulations. And I hate regulations too, but in the absence of real competition, I'm not sure what else we can do.
Well, and this is actually, it might not be so far off topic, because these .p2p and .bit actually would open up a lot of potential if used correctly and in conjunction with other services, maybe like open source hardware for that, where people could actually start competing in a decentralized and anonymous manner, correct?
In terms of net neutrality, this is very, very tangential. There is an issue in that one of the ways that they want to impose censorship on these systems is vicarious liability, and the RIAA or the MPAA thinks that they have a legal theory that they're basically going to start suing ISPs to start blocking sites, and using censorship circumvention networks, we can kind of make ISP level censorship go away. So that's positive.
One thing that most people don't seem to realize is you talked about it earlier about the certificate signing, but people really don't understand this. The only way to make sure you're talking to the person you're talking to is through this system of certification and DNS names, and that P2P is something that is something we need to guarantee our secure communication.
So let me talk about that for just a second. So right now, and if you go to the BitShares, youtube.com/BitShares, there's a SSL equals plain is roughly equivalent to plain text talk that you can watch that I am and it's part of the research that I'm working on to try to kind of move the industry in a way that makes it easier for BitShares.p2p to interoperate with the rest of the system, and make it so that we don't have to use, because right now we have to buy into the CA search system. But essentially, because of these faulty, we built these early security models around, the web security models were built with some very faulty human factors premises. So there are these premises about how humans behave and our cognitive, our processing capacities that are just simply not true. This essentially means that, cryptography's basic, especially public key cryptography's basic premise is that you can have trusted communications over untrusted channels. The certificate authority system and the web security model in specific makes this not true. It means that any network operator can arbitrarily man in the middle you right now, and they can use this man in the middle capability to skim all your passwords and see everything that you're doing, which is really, really scary. There is some technologies that are helping to fix this, and .p2p itself is its primary purpose is censorship resistance, but it will also fix that problem, and it will do it in such a way that will be very, very difficult for even governmental attackers to break, to subvert. So you can have nation states trying to man in the middle of your connection. They cannot arbitrarily do that to everybody, and there's caveats, like they can still break the server, or they can go and after the client computer itself. But the system itself is now outside it. The base system itself is outside of the attack of even a nation state. So you can start fixing those other areas, such as, making formally proven computer hardware and software, and making, kind of a Chromebook-esque thing that is very, 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 very secure. And our system itself will work with those future enhancements to the rest of the computing infrastructure.
Also, in case somebody's using a Lenovo, you have a malware installed that looks over your shoulder on every HTTPS connection you have.
Yeah, so we obviously, we can't fix everything, but we can make it so that we're no longer the weakest link, and that breaking our link is very, very difficult even for a governmental attacker. Although there is no laptop that can, there's local client security. It's very hard to do, and there are, it's still a plethora of 0 days for everything. In the distant future, when we have formally proven systems, and we have formally proven browser and a formally proven operating system, and you've got levels of auditing similar to that of the auditing that goes on to the Bitcoin code base, which someday I think we'll have. It means that we can still use our system, and it won't. And maybe the servers on the other end, if they're run by total ninjas, I guess. Yeah, we're now in the club of infrastructure that is resistant towards the most expensive and well-resourced adversaries out there.
Indolering, have you looked at any hardware or? Well, basically, okay. So I'm making this router, and the router is designed to fill. It's designed to run things like your .p2p client, so that everything behind it has the freest internet possible. I'm curious what you do with a router like that. I posted the specs there a minute ago, and we're getting closer and closer to actually making the thing ready to go. So, yeah, I'd like to hear what you think about that.
I think that increasing the number of devices that can resolve these types of addresses securely is great. I don't think that we should be putting our trust in routers necessarily. And the point of all this is to make it so that you can have trusted communications across untrusted networks. I don't think that we should have to trust our router to do that. And so
I wouldn't want people to exactly. It's more of a computer and less of a router. It's designed so that, well, first of all, the user can choose whatever OS they'd like. And secondly, it's not me or my company configuring it, although we're hoping to offer a package installation system. It's the user, and it's our hope that essentially they're going to be able to trust this thing as much as they can trust their computer.
Okay, so in regards to .p2p resolution, the system that we set up, it needs to be, there's essentially two different ways to do this. One is local lightweight resolvers, local lightweight clients, kind of like lightweight Bitcoin clients, except that since we don't need to worry about the currency aspects, we don't give a shit about double spends, we just call them resolvers. So those are very, very lightweight, and we think that they should be, that is how we are going to get levels of trust for systems like Tor, I2P, Freenet, that sort of thing. We want to build those into browsers, operating systems, and those decentralized networks. And I think that's how we're going to, I think our back door, because Mozilla is now including Tor by default. And I think our backdoor into these systems is, and kind of the more meta aspect of the systems that we're building, Namecoin and .p2p. Right now, .p2p is using BitShares. In the future, we're definitely going to need to move to a currency that's specifically designed for this, a currency that's designed as a trusted base for the internet. And so that sort of thing, that security model for that trusted base needs to be, local resolution on the computer itself. Now, the second way that we can do this is we can actually use DNSSEC. And what DNSSEC does, and the idea is that you actually have locally validating resolvers. So the operating system itself validates these issues, validates the DNS information, and it doesn't need to trust the router to provide correct information. And so I think that your router is great insofar that you can add .p2p and .bit resolution to the local DNS right there, but the encryption information itself, the verification of that information has to happen client side at the laptop level. And the interop system that I'm working on, and I guess we should probably take this opportunity to transition to what I'm asking for the delegates to do.
Bingo.
Is that the interop system that I'm building means that you don't need special, it uses threshold cryptography. Let me more try to address what you're saying first, in that we now don't, your router can provide that information, but we're making it so you don't have to do anything special with that router. Essentially, that router, you would just change the root DNS server that you trust or whatever, or you can import the .p2p zone files directly. But we shouldn't be placing trust in the router itself, if that makes sense.
Oh, totally. In fact, that's a really awesome addition to the security model. On the pages where users would configure things like support for these anti-censorship networks, so can you tell me a little bit, not just about the Mozilla Tor browser, but like how the verification systems are working, or how you plan for them to work?
We are working, the two systems are local resolution on the client side, which means that you have a lightweight resolver, and that lightweight resolver acts as a DNS server. So you have middleware, which is it's right now it's called NMC control. We're going to rename it to name control so that it's neutral and both BitShares and Namecoin can use it. So there's that way, and the other way to do this is this backwards interop system. The backwards interop system, it sacrifices a few things. It sacrifices some of the security. It will be at least as secure as a traditional TLD system. And as time progresses and as we're able to improve the system itself, it will be more secure than traditional TLDs. And so what this does is essentially right now with DNSSEC, you have to trust the TLD operators to provide information, the correct information. And so what one of the security delegate that, I'm asking for 3 delegates, one for funding my work, which is primarily usability and engineering stuff with the middleware. The security delegate is actually funding work towards this threshold cryptography solution, as well as setting up these secure delegates. So the thing about third-party trust, there's a lot of different forms of third-party trust. I like to call the CA search system a siloed type of trust. And there's something called DNS chain that I've been having to deal a lot with, that they are kind of doing something similar to what you're talking about, and that they're placing all their trust in these routers and hoping that these routers never get popped. That's interesting, but we don't need to design the system to be dependent on these routers and the local resolvers in those routers.
I'm in complete agreement there, actually. I hadn't thought about extending the security model to client PCs, but that's just better. And so now when I'm thinking about it, in the router, I'd have installation instructions for the clients, because
let me finish with the backwards interrupt solution.
Yeah.
So you shouldn't. So the backwards interrupt solution means that they won't need to install anything. Okay. So the backwards interrupt solution, what it does is it basically takes third party. There's always this existential crisis of who can you trust and what can you know. And the best form of third party trust is one that is distributed. And so you have multiple organizations, independent entities, and this is what, as opposed to siloed trust. With siloed trust, what you have is a system with the CA certificate authorities, right? So you have all these notaries. In the current system, all these notaries can create a valid certificate for any domain name. And there's, 600 damn notaries, 650 notaries. Every major government can produce these. Any organized crime syndicate, anybody with basically $50,000 can produce their own certificates for any other website. And so the problem with this is that every additional notary accumulates security vulnerabilities. And if we had anchored things like DNS chain wants to do, if you want to anchor these things to routers, every router manufacturer adds additional security vulnerabilities. Not as bad as the CH certificate system, but you're locked into trusting these router manufacturers and their install base, and the trust is there, and people buy into that trust based on feature sets of the router, not necessarily trustworthiness of the router itself. But what we can do instead is we can distribute trust. And so what we can do is we can have independent organizations, and in our case we're going to have independent delegates taking this blockchain information that is trustless, in that you trust the math of who owns which address, and the encryption certificate, the encryption information, and you have 7 or so different delegates all looking at producing the blockchain, saying this is the blockchain, this is my signature for it, and as soon as 4 out of 7 of those delegates produce these zone exports that are that they have cryptographically verified, they're able to produce another, this what's called a threshold signature. So this threshold signature can only be produced when 4 out of 7 of those delegates have all produced their own zone certificate. And I might be screwing some of this up. So I'm not the security engineer. I'm hiring someone else to deal with this. So it's actually a version of RSA, threshold cryptography, and it's a very advanced version that it was actually we're kind of lucky in that there's an academic who outlined one such system, but it hasn't been implemented. So we need to re-implement this thing, and that's what we're working on doing. And so as the delegates, if they produce this, they can produce these zone files, and it's all signed off by this threshold signature. And the client themselves, as RSA, or not, as DNSSEC local validation becomes popular, as computers start validating their DNS information, they will store this master public key, this threshold key that they produce. And so you as the router, which is great because you as the router can just import these zone files, which is very easy, not very computationally intensive. Even standard routers will be able to do this, which is not the case for light resolvers. Standard routers can't handle the computational needs for even lightweight resolvers. All you're doing is you're just importing these zone exports, and you say, here's the key that's signed off, and the client computer itself is trusting that threshold key. So that's how the verification happens in the other, in this backwards interop system, is that you trust 4 to 7 delegates to produce a valid copy of the blockchain. There's a question about how, what if you lose trust? Essentially, how do you change trust in these delegates if you lose trust in one of the delegates? So there's essentially what we do is we actually have a master, what's called a key signing key. And this is an offline key, and we have 7 people that we trust, each one living in a different jurisdiction. That is the key that everyone trusts locally. And this key is then used to sign off on a zone signing key. And that zone signing key is another threshold key that the delegates are using. So it's kind of like having a hot wallet and a cold wallet, insofar that at some point, if we lose trust in the zone signing delegate, we can kick them out, and the 7 key signing key holders who are different can sign off on a new zone signing key. And so it's much easier to change that zone signing key. If we have to, if you have to change the zone signing key, which isn't as big of a deal, because if there's, you have to compromise 4 of 7 people, and changing these zone signing keys is kind of a pain in the ass. And so if one person goes away, if we go, okay, there's one person we can't trust anymore, but we still have 6 of the 7, let's just wait until the next time we all happen to be in the same room to choose a new new key signing key person. So what happens if you absolutely have to revoke trust in the key signing key? What you do is you create a new one, and you sign the new key signing key with the old key signing key, and you basically wait for all the client side software to update to the new key signing key. And so there's a short interim period where you still have everything working. They're somewhat vulnerable to it. If for some reason you had 4 out of 7 that all lost their keys, they're somewhat vulnerable. But as soon as, like any information security system, you update all the clients as quickly as you can, and you deal with it like that. Just as if there was if there's a problem in the lightweight resolver and there's a security compromise, you have to get everybody to update as quickly as possible. So it's that game of how quickly can you update. There's another question you're asking: is zone signing certificates expire regularly? Yes, we can do that. We would prefer not to do that. The ICANN itself, they have a system where they don't use threshold cryptography. The key signing key they use a shared secret scheme, and so everyone combines. It's more like the Lord of the Rings thing, where everybody, well, I don't know if it's more like that, but everybody combines their shared secret to reproduce that master key signing key, or whatever, and then sign the new zone signing key. That might not be perfectly technically correct, but the reason that they do that is because their zone signing key is only 1 kilobyte. kilobit in length, and that is a very short key, so they redo that every 3 months. There's also some other reasons having to do with basically like testing to make sure we can actually do this. But we'll be using a 2 kilobyte key for now, and then upgrading as the tech, as we need to, upgrading the key length. So we won't need to do that every 3 months, maybe a year, maybe 2 years. I don't know the exact timelines, but we would like to save some money, and since we're using threshold cryptography to begin with, which makes it more difficult to do all these things, we would like to not have to re-sign. We would like to not have to generate a new zone signing key unless we kind of need to.
I'm just going to interrupt here. We are sitting at about an hour and 9 minutes, and this is, of course, Indolering has stated that he is interested in doing these types of hangouts again. So I really would like to focus for a couple minutes toward the end on really allowing Indolering to explain what his delegates are going to be doing in depth as far as the delegates he's wanting to have with the funding from. And Solomon actually kind of got to the root of the question here. What kind of metric are you going to be using to help us figure out what you're adding to the market cap with the help of building up .p2p functionality?
Sorry, like put differently, like how are your delegates increasing the demand for BitShares?
Okay, so there's two kind of ways. I mean, kind of the soft way is we're going to set up a experimental, x.p2p top level, second level domain. So there's, it's kind of like co.uk. So there's that. There'll be some activity there. The long term will be, as Toast has talked about, he wants to boot up a whole new currency specifically designed for this task. And that's, we're looking, 6 months to a year out on that. We'll share drop on the rest of the BitShares community as a way of repaying for support of .p2p as is now. I'm not sure what the share drop is, and I should add a caveat that I haven't run that specific verbiage past Toast or anyone else. We could also launch on BitShares directly. I'm not a systems programmer, and that's kind of Toast's job, and the other people exactly how they want to implement these things. I think we can also just run on the BitShares chain for a while. We don't necessarily need to create the lightweight resolvers right away. It's the current code base makes that a little difficult, but again, I need to talk about that with Toast. I'm kind of talking a little out of turn here. If we launch on BitShares, what will happen is all the domain purchases, all those BitShares are just destroyed. And so that, that goes back into the community itself. That goes back into as what Toast, or as what Bytemaster said, was that you are using, we're creating a reason to buy BitShares, right? That is one of the reasons you gotta have, if you want to pump up your price, you have to have reasons to buy it. And so that's what we're trying, and that's what it will do. Where we launch on which chain is kind of up in the air at the moment. We could do it directly on BitShares. We could do it on a new chain. But if we do it on a new chain, of course, the BitShares community would be properly compensated for sustaining development.
And that launch will be like 6 to 12 months in?
I should not give hard deadlines like that. Maybe. How's that? I'm not working on the systems level programming stuff. I'm doing the backwards interoperability solution. I'm working on the middleware stuff, and I'm trying to work through the best way to kind of architect, if we do move to a new currency, to architect it and how. And a bunch of usability issues. You have to deal with stuff. Well, I'll get to that in a second. there's a couple questions on the side here, like would bit assets be useful for the system? Absolutely. And one of the arguments for launching on BitShares is that, you already have bit assets and you already have price feeds and you already have all this great infrastructure, which makes a lot of sense to me. Kind of the main argument, I think, against launching on BitShares is there's a decentralized, a distributed trusted base for the internet doesn't require 10-second block times. There's a bunch of other things that would make it, maybe easier with a different kind of code base, but we'll see.
Is there a danger to something like proof of work in your mind?
They're different. On the one hand, some of the downsides of BitShares, and the reason that I'm working on, multiple different things, some of the downsides are, the code base is not as heavily scrutinized as with Bitcoins. The delegates enable us to do a lot of cool stuff. And in fact, I altered the .p2p roadmap because I think in terms of the interaction with the IETF and ICANN and how we, I can't talk to that right now because I've actually had to really step back from talking publicly about the politics of everything because that's very, very complicated and it's a very changing situation. But with delegated proof of work, you can do interesting things like if someone loses their private key, you can give it back to them, right? You have a system, you'd have 51 delegates say, okay, the contact information on this points to this person. We've talked to that person. It has been 2 or 3 months, and no one else has come forward that has a that can say, hey, this other person stole this from me, or no, it's not really me that made this request to change who owns this domain. So you can do things like that with delegated proof of stake. You could also, I'm not going to go too far into the other interesting things you can do. But I'm sorry, and let me explain. There's politics. There's 2 big standards bodies. There has been 20 years of fighting about having different roots and different domain name systems, and it's very, very messy, and it's very a lot of hard feelings all around. And we don't want to create a different root. We want to work within these standards bodies. There's also a lot of people that, just the certificate authorities, even though we don't think that they're providing a whole lot of value and that they're, that what they're signing is kind of arbitrary, they are still trying to do the best job that they can, and they're trying to do the best job they can, and they don't like doing weird stuff. So there's a new proposal to start generating TLS certificates for .onion addresses, these Tor hidden service addresses. And that's even that, which seems like a fairly straightforward thing. Like, yeah, sure, it's okay to sign certificates for that. That is requiring, a vote, and the browser vendors are definitely interested and engaged with that kind of discussion. So trying to speculate on exactly what the ICANN and IETF, what we can and can't do, and the future of all that is kind of difficult because it takes a long time in politics. It takes a long time to get to a final resolution. I don't want to spoil anything by making declarations about stuff that haven't been passed yet. Someone on the side here said something about bit assets having its known volume on its own .p2p chain. This is, so that is actually one of the concerns. We can also do price feeds, but there's a lot of back and forth about which chain is best and for how long we should stay on the BitShares chain.
If this comes to pass that you decide to move it off of the BitShares chain and make it its own, essentially, its own DNS type of DAC that serves the function separate from BitShares, are you interested in, we have this idea in the community that it would be a good thing to promote these different chains that are powered by delegated proof of stake as powered by BitShares. Do you have any ideas or thoughts regarding that proposal?
There are different architectural decisions you have to make. I think that certainly, it depends on the community and whether you want to. I think that delegated proof of stake and I think that DAC is very confusing for a lot of people. So I think that it is helpful to promote different chains that show off different aspects of these models, of these different work systems or proof systems, trust systems. I can't speak to any specific one or say whether that's a good idea or not in general.
Can you say what you're doing at the moment and like what your plan is? But when do you want to launch the delegates and what hinders you from doing it?
Right now, what I'm working on middleware and also trying to standardize and harmonize between the two communities. I'm also trying to work. I'm getting into. I kind of got into some hot water because I have been relying on outside people for information about the IETF and ICANN processes. And so I am now getting into that. I can't make any promises with regards to those communities because it is, I did a lot of work in politics and it sucks because the politician, you're elected to go and do a bunch of stuff that you kind of don't have the power to do necessarily. And most of your job is dependent on external factors. So I don't want to make too strong of a statement of what I'll be able to accomplish within those communities, but I would like to start talking and start that process of finding out those communities and introducing .2p2p and these concepts to these other communities. And then I personally, for the delegate stuff, I'm working on very tough usability issues. So one of the things that we had to figure out, for example, is the certificate, this encryption information. And someone just asked in the chat channel, the communities, what communities? ICANN, the IETF, and other standards bodies. Those are the communities that I need to be interacting with, and I need to be liaisoning with and trying to push new ideas. So, for example, one of the core things that we need is adoption by the browsers of DANE, which is basically this DNSSEC, the idea of putting the certificates in the DNS records, the encryption information or the cryptographic information in the DNS records. There is an existing standard for that, but support has stalled out for various reasons. And if you go and you look at the talk I gave for BitShares, this SSL is roughly equivalent to plaintext. The newest version of that talk basically goes into why this support stalled out. And so for right now, if you have a lightweight resolver, it's a huge pain in the ass to try and get the encryption information and validate the encryption information in a secure way. You have to set up this proxy system, and you have to proxy all the connections to the computer. And then as things come in, you check the certificate. And if the certificate is what it says in the DNS record, you sign that certificate with a public key that, with a certificate that you've seeded in the operating system or the browser's trust base. You have to pre-seed all these trust bases, and then you have to sign that certificate. It's a kind of a really ugly hack, but it would be great if the browsers themselves just supported checking this encryption information by default, supported checking the encryption information through the DNS records in a native way. And so one of the things I'm trying to do is kind of popularize this and working on some human factors stuff. I've got contacts in the research world, and I'm trying to package this in a way that, it is not directly promoting .p2p, but it is promoting one of these core technologies. So work like that is important because we want a much smoother integration path. Then there's other interesting things like, before you'd go to one of these certificate authorities and you say, here's my certificate, sign it, and you just install that on your computer and on the server, and everything was all good. Now we have to create these clients that will automatically, you not only have to sign these certificates, you have to create your own kind of you have to turn yourself into your own certificate authority. and that you have to have one of these offline certificates that say, this is the thing that's okay for me. If this certificate signs any of these other certificates, this is the one that you trust, so that you can have 10 different servers and each one can have their own SSL certificate. As long as it's been signed by that master certificate, I'm not sure if I'm using the right wording, but my apologies if I'm not using the right wording. But that's a whole new, workflow that we have to get people used to. And the management of all this stuff is all very, very hard and very complicated. So that's the kind of stuff I'll be working on in the next year. Currently, Delegate Pay is only able to pay me at about quarter time of what my regular rate would be. And so it is complementary towards when I'm working on getting a bunch of government grants towards supplement my income so that I can work on all this other stuff. So that's primarily what my delegate will be paying for. The other delegate is the security. I've been asked to kind of wrap this up, so I'll try to be brief here. So the other one is the security delegate, which is that zone signing infrastructure that I talked about before, re-implementing that really advanced threshold encryption RSA cryptography, and also setting up, because you need to run really, really secure delegates. So we're going to have, if not an image that people use, we'll have we'll automate the setup for those servers. Also, we need to set up demonstration servers and come up with a very, very secure system. And that requires owning the actual physical servers. So setting all that up and paying someone to do that, I'm a usability engineer. You guys are able to pay me, 1/4 of my, my market rate. The security engineer, you're only able to cover about 1/8 of what a security engineer's salary would be. So, but that will be enough to cover that initial, to get that initial zone signing system set up. And then I have an operational expenses delegate, a third one, and that one basically covers things like the hardware costs for setting these things up. So we're going to set up 2 demonstration servers. That requires having, owning the physical server and renting rack space. So we have to go buy that server. We have to go buy basically a second server, because we're separating where the signing for these zones happen on this second server. That's all very, very, we have to pay for all those things. It might make sense to have me go to fly me out to, for example, an ICANN or an IETF meeting. And that would be paid for out of the operational expense delegate as well. The operational expense delegate, it'll be running at the 100% rate, but I will have a strict accounting system, and I will not cash out on those things unless it's unless I know that purchase is going to happen or I have the exact prices for that. So all of that will stay in BitShares for the operational expense delegate. Anything that we do not end up using will just be destroyed. We'll just burn it. Because of my financial situation, I will need to be cashing out on my delegate pretty regularly. But I believe the security engineer that I'm talking to, I think that the majority of it he would like to just keep in BitShares, so it shouldn't be pushing on the exchange rate as much either.
As a summary, one could say, so on the one side you're doing the design, and on the other side you're also doing kind of the politics, talking to different groups and businesses that would be necessary to get into the boat for the .p2p system to get mainstream adoption, or even close to mainstream adoption.
Right. So I would say it's not so much as me getting to the boat as architecting kind of a plan and getting familiar with those communities and seeing what's possible and doing those things.
That makes sense. And so there's one question left, and which is, so if you're talking to those different communities as a BitShares delegate, you're advertising, or like you're making a plan and proposing this plan you set up for .p2p, and you're not, or are you also describing your personal vision, or your personal position, which involves .p2p, but also involves Namecoin and their solution? So could it be that from talking to those different communities and businesses, it could result that Namecoin gets adoption instead of .p2p? Is that a danger?
No, because I think that the two communities want very different things. And that's kind of something that I'm finding out now as I'm working through it. And BitShares is able to do a lot of things that .bit can't. Those are strengths and weaknesses. So, and I don't want to say too much. Like I said, delicate kind of conversations that need to happen. But I think that they're going to be two very different solutions. And kind of the initial trouble I ran into was saying, hey, I'll just say, the same thing goes for P2P that goes with .bit, and that's not true, because I think .bit community wants something different.
Next time when you come around, you can talk about that, because that's very interesting. What the differences are in terms of the goals.
Mm-hmm. The primary one I think is that .p2p is primarily focused on resolution of Tor, Freenet, and I2P, and being distinct from the traditional domain name system, that they are more focused on that. And I don't want to screw up the politics on this, but as I learn more, and I want to be upfront, I'm very new to these communities, and you really shouldn't hire me if the main part you should be hiring me for is trying to architect a solution for .p2p, working on these hard usability issues, and trying to work with Toast towards figuring out the the overall architectural stuff for .p2p. And all this other politics stuff should be a minor component, or should be seen as the kind of this different component of what I'm doing, because I can't guarantee results with it. But yeah, I think that's primarily, with .bit, it's very, they don't have delegates, so setting up these really secure servers for .bit is going to be really, really hard for for doing backwards interop sort of stuff.
And I guess we've already talked a little bit about the potential of inviting some of the community on here to actually kind of be part of some of these hangouts and really kind of express themselves and what their opinions are on this project. So I look forward to it, and I'm going to have to cut us off because, man, I would sit here for 2-3 hours talking about this project. And I'm sure everybody else who's here would probably do the same. You guys, you've really gotten people talking. Indolering. But with that said, if you would kindly reach out to the people who are planning on working with you, it might be a good idea to see if they would be interested in maybe meeting the community, if they're, if that's in the cards. Okay. And maybe we can reach out to Toast and see if he could come on and chat a little bit with us at some point in time.
Yeah, that'd be great. I'll talk to. We'll see. The thing with the same thing I'm sure with .p2p, but BitShare or the Namecoin people, there is no funding for them. No one's getting paid to work on that, so they're all we're all very we have very little bandwidth, and so the thing that as somebody just said, it's all open source, so all the and my primary technical contribution will be dual use the middleware and all the other stuff will all be dual use with BitShares, and that's what I'm going to be focusing on, and that's what you should be primarily paying me to do, is making sure that it will be dual use for BitShares as well, so that you guys can use all this technology. And so with the BitShares guys, I'd love to have them on. We'll see if they have time to do it. I have a hard time trying to get people for their meetings, but I'd love to have some of them on, and maybe I'll bring on the security engineer and he can talk about what's going on, and that'd be great.
Roadscape asks a very valid question here that probably I wouldn't have asked. How can we help your efforts other than beyond the obvious, which is the delegates?
I could use some feedback on my presentations. I could, if anybody out there is in the academic world, I'm reaching out for some mentoring with some other people that I know, but I do need some mentoring in those areas. If you're interested in helping out with the coding side, send me an email, Indolering at gmail.com is probably the easiest one right now. But you just go to indolering.com and you find all my contact information. Yeah, if you have contacts in IETF, ICANN, certificate authorities, DNS providers, give me a holler. I would love to, I'd love to chat with you.
Well, thank you very much for connecting with us. And we look forward to having future Hangouts with you. And of course, if you are interested, like you've stated that you might be, if you have any content that you would like us to also post to the Beyond Bitcoin site, we'd be more than happy to kind of help direct people to your content and your own blog.
Cool. Yeah, that'd be great.
All right. Have a good one, man.
You too. Yeah, reach out to me.
Well,
and thank you so much for having me out.
Of course.
Yeah, thanks.